What if we looked at Reason as an instrument you could play? A virtual studio rack of sounds and effects, made tangible through hardware sequencers. Imagine bringing this powerful instrument into a live setting. How would that change your creative flow? Hey, I'm Beyun, and welcome to my studio. Earlier this year, Reason Studios premiered the recording of a masterclass I gave at Amsterdam Dance Event last October. This talk explored using Reason and hardware in a live set, taking the tangibility, immediacy, and workflow I love about hardware sequencing, coupled with the accessibility and flexibility of software as a source of sound. Today, I'll dive into more specifics about the setup so you can follow along on my screen. I'll also revisit the studio workflow ideas I shared, expanding on a few details. And at the end, I'll give a little preview of where I'm taking this project. The biggest issue you'll face when working with hardware and software is keeping everything in sync. This is where the Multiclock comes in. In a live set, the Multiclock acts as the clock source, meaning I start and stop all the MIDI by pressing play and stop on the Multiclock. The Reason timeline is never running. Instead, Reason listens to MIDI from the machines and produces sound from that. The MIDI clock signal goes through each of the 4 output ports on the Multiclock and into each piece of gear: Elektron Octatrack, Analog RYTM, Arturia KeyStep Pro, and the RE303. Like a conductor, it tells each instrument where the beat is. You can also configure an offset per channel on the Multiclock to account for latency individually introduced by each piece of gear. Another feature I like is the ability to mute the clock on any of these channels, allowing you to stop and start hardware on beat in the middle of a live set. Cued by the Multiclock, the RE303, RYTM, and Octatrack send their audio signals to my PreSonus Quantum 2626 audio interface. The 2626 is a Thunderbolt 3 interface with extremely low latency, a full stop requirement in a live setting. The MIDI from the hardware should trigger a near instantaneous sound from the software. Having any noticeable delay would be unacceptable. This Quantum 2626 then goes into my M1 Mac Mini, which runs Reason 12. The main requirement is support for Thunderbolt 3. You can decide on the remaining specs depending on how complex the live set becomes. The Octatrack and KeyStep Pro both send MIDI into Reason. The mapping of MIDI information to instruments in Reason is configured in the advanced MIDI device. Let's dive into that. I can choose between 4 buses in the advanced MIDI device, which you can configure in the sync settings of the Reason Preferences menu. I'm only concerned with bus B and C for this live set, where bus B listens to MIDI from the KeyStep Pro, and bus C listens to MIDI from the ESI MIDI Mate. The MIDI Mate is connected to the MIDI out of the Octatrack, since Elektron made a design decision not to send the Octatrack's MIDI out over USB. I could have also used the MIDI input of the Quantum 2626 to listen to the Octatrack's MIDI out, but this was an early design decision that stuck. Looking at the setup in advanced MIDI, in bus B for KeyStep Pro, I'm listening to MIDI from channels 2, 3, 4, and 5 from the 4 tracks on the KeyStep. In the drop-down, I route the MIDI to a combinator, 1 for each channel. We'll jump into that in a bit. In bus C for the Octatrack, we listen to channels 9 through 16 from each of the 8 MIDI tracks of the Octatrack. In the drop-down for each channel, I also route the MIDI to a combinator, a total of 8 different combinators for the Octatrack. Before we get into the combinators, let's go to the mixer. Here, I have the audio channels taking in live audio from the RYTM, the Octatrack, and the RE303. Then there's the audio coming from the 8 Octatrack combinators and the 4 KeyStep combinators. Also note that some Octatrack sends have automation on them. We'll get to that later. Now for the combinators. To keep things simple, each of the 4 KeyStep combinators has Arturia's analog lab loaded into each of them. This gives me a few sonic elements for the keyboard. For instance, strings, pads, bass, and a lead. I've also remote mapped the patch selection buttons on each analog lab to the buttons on my launch control, as I don't want to be clicking my mouse around in the middle of a live set trying to change those patches. I also loaded a grain sample manipulator in the first keystep combinator to demonstrate how you might switch between multiple devices in a combinator. I've added 2 switches in the panel area, which you can do by going to Editor, Configure, and clicking Switch. If I turn on the first switch, I get the sound from the Analog Lab strings. If I turn on only the second switch, I get the sound of the grain sample manipulator. And if I have both on, well, both of them play. In the main editor menu, notice that the key range display next to each instrument is toggled on and off when the switch corresponding to that instrument is toggled. If we click into the instrument options, notice that the switch is set to target the receive notes. When it's on, the device accepts MIDI. When it's off, it ignores MIDI. If we examine the Octatrack combinators, notice that the switches here have automation enabled, marked by the green outline. Let's jump into the Reason sequencer before diving deeper into the Octatrack combinators to understand what's going on with the automation. The first thing you might notice is that the Reason sequencer looks different than what we're used to. There's no audio or MIDI, only automation. I'm going to call the Reason sequencer view the timeline from this point forward, as it's not sequencing anything in this example, and I want to reduce the confusion with the hardware sequencing that's happening externally. Each bar contains automation settings for a song, with some bars acting as transitions between 2 songs that utilize an overlapping set of combinators. If we expand the combinator automation lanes, you can see that the automation blocks in full color toggle on the switches for the active devices in the combinators for that song. The grayed out automation blocks also toggle switches on. However, the gray just indicates that those devices transition into or away from the adjacent bar or song. This is a color coding scheme that I came up with. You're free to do whatever you want with this one. Just note that the automation in each bar determines what switch is on in a given combinator. Since Reason is not the clock source in this configuration, the timeline is not running when the multiclock is running, so there's no looping happening anywhere in this timeline. As I advance from one bar to the next, all this is doing is toggling combinator switches and adjusting additional automation for track sends and tempo. To make jumping from one song setting or bar to the next more accessible, I've remote mapped the fast forward and rewind buttons here to my launch control. I'm then able to jump around the timeline without using a mouse. At the top, in the transport automation section, I've automated the tempo changes so that effects like delays stay in sync with the target tempo of each song. However, in this example, the tempo in Reason and the tempo in the multiclock are not synced. This means I must remember to match the tempos as I advance to the next song or bar in the timeline. Keep in mind that this example was purposely created as an accessible proof of concept, with no extra software required. However, in a live setting, you can imagine it's quite a lot of cognitive overhead to remember to advance the timeline and update the tempo on the multiclock while changing the Octatrack and the rhythm patterns and playing a chord and twisting the knobs on the RE303. While this issue might be manageable with practice, another problem is that the linear format of organizing the songs this way removes the option for spontaneity and improvisation in a live set. With this configuration, it's just not possible to switch between any 2 songs or play a song at a tempo it wasn't originally written for. So I have a solution. Since ADE, I've had the chance to make several improvements to my live set, including writing a script to keep the multiclock and Reason in sync. In that scenario, I listened to a clock signal from the Octatrack's MIDI through with the other MIDI-mate port. The script listens to the clock ticks coming from this input. When the tempo changes on the ERM multiclock, the script detects the change and automatically updates the tempo in Reason. I also wrote software that sits as a layer between the MIDI out from the Octatrack and Reason to listen for program changes when switching patterns on the Octatrack. This software automatically toggles combinator switches and other settings in Reason so that the automation information in the timeline is no longer needed. However, getting into that right now is out of scope for today. For now, let's focus on understanding this paradigm shift for how we use Reason. I want to enable folks to get started easily without needing to run scripts in terminal. The advanced stuff, we'll get to that in another video. Now, back to the Octatrack combinators. This example uses several NNXTs within each combinator that respond to MIDI from the Octatrack depending on which of them is turned on via a switch in the top panel. As you can see, some of the NNXTs have effects applied to them. I decided to chain the effects after the NNXT and the Combinator instead of putting the effects in Ascend, since that effect was very essential to that sound. Looking in the editor, the effects applied to the NNXT are also turned on or off with the same switch that toggles the receive notes function on the NNXT. You can also see that I've added a knob to each Combinator. This knob controls the cutoff frequency of the NNXT, which I've limited to a specific range depending on the NNXT and its sample. And also, each one of these filter knobs is remote mapped to a knob on my launch control. As I move between bars on the timeline with the launch control, you can see the switch automation in each Combinator change. However, the filter knob is not automated. That's a separate control for me to play with in real time that changes the character of the sound coming out of the NNXT. Let's flip around to the back of the Reason rack. Notice how each device or sound is routed to the back of the Combinator mixer here. When you flip back to the front, you can see the names of the devices routed to the Combinator mix channels here. A nice tip for organization. Lastly, we have the Effects Combinator for the RE303. This effect is applied to the live audio from my RE303 via routing to the effects bus here. I can toggle between a dreamier or more aggressive, overdriven sound here. You can also see that when I toggle the switch on the Combinator, the device bypass or on switches are also toggled, depending on which device I want affecting the sound. Alright, let's jam with the setup. You can watch the ADE Masterclass for a longer version of this jam, but I will do an abbreviated jam here so you can follow along on the screen. Next, I'd like to explore ideas for merging hardware and software in the studio to make the ideation workflow more fluid. When I'm generating ideas, both for a live set and for a track, I really enjoy creating drum patterns with hardware. Especially with Elektron gear, I'm fond of conditional trigs, trigger locks, and the ability to write polymetric rhythms by varying each track's pattern length. However, I'm not fond of menu diving when selecting drum samples, and that's where this Reason workflow comes in. With this setup, I'm sending MIDI from my rhythm to Combinators in Reason, just like I've been doing with the keystep and the Octatrack. This setup allows me to use my favorite VST to audition and select samples in a very fluid visual way, as you will see in just a moment. Once I've chosen the samples I want and I'm satisfied with the sketch, I'll load those samples to the rhythm. I'll then apply the already created pattern from the sketch to a new kit of natively hosted samples, so only audio comes from the rhythm, not MIDI, and I'll use that for my live set. This setup also allows me to record the hardware MIDI and contain the samples to recreate everything later. This information is helpful if I wipe the patterns from my hardware and rediscover something great about the track later and want to recreate it. All right, let's dive into this studio workflow. Like with the live set, let's focus first on the multiclock. In the live set, the multiclock is the clock source. However, in this example, Reason is the clock source. That's because we want to record the MIDI information coming back from the hardware and have it aligned with the grid on the Reason sequencer. To do this, on the multiclock, I've changed the source from internal to audio in. In this configuration, the timing information comes from a click track in Reason via the third audio output on the Quantum 2626. The click track is generated by ERM's Multiclock VST. Here you can see I've configured the time signature to 8/8, which is the default setting. I then have a cable carrying the audio signal from the output 3 on the 2626 to the audio input on the ERM multiclock. Using a click track to sync Reason with a multiclock provides the least amount of latency compared to using USB. That's one of the reasons why I actually opted for the multiclock in the first place. I then go to Preferences, Sync Settings, and make sure the ERM is selected for the output of the MIDI clock sync. I also have Send MIDI Clock while the sequencer is stop checked, as well as Send Stop Continue when repositioning. However, I uncheck the option to send song position. In the transport panel below, I make sure the sync mode of Reason is set to internal and Send Clock is selected. When I start the Reason sequencer, the multiclock will listen to the click track for the first measure and then send the MIDI clock out to the rest of the gear. The audio and MIDI return to Reason are then aligned to the grid. Of course, some initial calibration was involved in adjusting the latency settings on the multiclock. That calibration process is a little bit too involved for today, so I'll show you the offsets I have set up on each channel on the multiclock now, and if you have a similar setup, you can use that as a starting point. The nice thing about the multiclock is that you also have access to shifting the offset forward or backward per channel with the shift knob up here. To get the rhythm sending MIDI to Reason, we also need to make sure it's configured properly, so let's look at that. On the rhythm, I've configured tracks 3, 7, 9, and 11 to send MIDI out on channel 11, and the other tracks send MIDI out on channel 10. The auto channel is configured to 3, effects on channel 13, and performance on channel 14. The important thing to note is that the VST I use to audition my samples in Reason only supports a maximum of 8 sample slots. Since there are 12 rhythm tracks, I've split them into 2 channel groups. Additionally, you want to ensure that the rhythm's auto effects and performance channels differ from the track channels. I also have another reason for organizing the rhythm tracks this way, but that's for another video. Another thing to note about the track settings is that each track has no machine applied on the synth page. The sample is also set to off on the sample page. Lastly, going into the Advanced Trigs menu with function trig, I have Send MIDI checked for all the tracks. Back in Reason, looking at Advanced MIDI Bus D, which is listening to MIDI from the rhythm, I have channels 10 and 11 configured to forward MIDI to 2 combinators, Rhythm A sketch and Rhythm B sketch. Alright, let's take a look at how these rhythm combinators are set up. Looking at the Rhythm A sketch combinator, you'll see 3 instances of this XLN Audio XO VST. I have 3 of them per rhythm combinator because I really like to layer my drum samples. The MIDI will trigger all 3 VSTs at once, allowing me to audition layers of samples with my patterns. Today, we'll only focus on one layer. Now, let's look at this mysterious XO VST. The thing I love about the XO is that you can load your entire sample library into it, and the XO organizes each sample into this visual cloud display. Everything is color-coded based on similarity, and over time you develop an intuition of where a particular sound might be. For instance, I know the sub-ear kicks are down here, while the thin hats are up here, claps are over here in the pink and sometimes blue, and snares are generally over here in the blue. You can also filter the samples by sample type, samples you've marked as favorites, frequency, length, drumminess, and sample folders. You can also search your samples with keywords. For instance, if I only want 808 samples, I type 808 into the search and the samples with 808 in the name or the file path show up in the cloud. Let's build a pattern on the rhythm. Starting with the kick, I put a pattern on the rhythm BD track. The MIDI gets sent to the kick 1 slot on the XO. I can then arm the sample selection for this kick and begin auditioning kicks from the cloud while the pattern plays on the rhythm. By the way, I don't have the multiclock running here as I only want the rhythm sequencer to be running. All the other hardware should stay asleep. If I want to add a snare, I'll go to track 2 on the rhythm and put in my snare pattern. The MIDI for this track gets sent to the snare slot on the XO, and I can start auditioning a snare sample from that XO cloud. You can immediately see how fluid and fun it can be with this workflow to create a drum pattern with fresh samples without doing any menu diving. A lot of happy accidents and unique combinations happen this way. Before we move forward, I want to highlight how I've gotten each rhythm track to send MIDI to a specific slot on the XO. I do this by incrementing the note value on the trig page for each track, as shown here. On channel 10, track 1 goes to kick 1, 5 goes to kick 2, 2 goes to snare, 4 goes to clap, 10 goes to close hi-hat, 12 goes to open hi-hat, 6 goes to flex 1, and 8 goes to flex 2. Then, when I'm opening the Rhythm B XO on channel 11, track 3 goes to kick 1, track 7 goes to kick 2, track 9 goes to flex 1, and track 11 goes to flex 2. Alright, that is a lot of setup. To speed things up, I recommend making a kit and a pattern with just the note value set and tracks configured for MIDI without any trigger information. Then you can copy and paste this pattern all over the slots in a single bank, and you have your whole bank ready to start sketching drum patterns with your rhythm and reason. Alright, I have a drum pattern ready to go. I also have samples and NNXTs triggered by the Octatrack, and I also have a string patch I'd like to play with a key step. Let's say I want to record all of the MIDI into the project so I can review it later. You can see that when I try to enable multiple MIDI recording lanes, I'm unable to do so. I can only enable recording on the MIDI lane that is active. However, if I right-click on a MIDI lane, for instance Rhythm A sketch here, and click Lock Rhythm A to this device, and in Rhythm B I click Lock Rhythm B to this device, recording is now enabled on both lanes, no matter which other lane I click to. To record enable all of these lanes, I repeat this process to right-click and lock a MIDI device to any MIDI lane I want to record. Now you're probably looking at your Reason setup and only seeing a list of plugged-in MIDI controllers in this list, or maybe nothing at all. To configure what shows up here, you need to go to Preferences, MIDI, and add a keyboard or control surface to this list. And it must have the green check enabled. For each recording lane, I've manually added a virtual MIDI device. To do this, I go to Add Manually and select Other for the manufacturer, then MIDI multi-channel control surface for the model. I give it a unique name and select an input from this list of available MIDI inputs. As you can see, reusing an existing MIDI input is possible, but you will end up with a warning icon next to the added control surface. That's fine, you can lock surfaces that have a warning icon next to it rather than a green check. However, to stay organized, I recommend going through this process I'm about to describe. To add a new virtual MIDI input, I go to Audio MIDI Setup on my Mac. Sorry, Windows users, you're on your own here. I then go to Window, Show MIDI Studio, then I double-click on the IAC driver icon. I add a port to the list of ports here and give it a meaningful name. Finally, I hit Apply and the new port is saved. However, when I go back to Reason Preferences MIDI, you will see that all of my virtual devices now have a stop sign next to them, and the MIDI recording lanes I had locked to a device earlier have all had the recording disabled. Additionally, when I right-click, I no longer have the option to lock this lane to a device. To avoid this situation, I really recommend adding all the ports to the IAC driver first. Then you can add the virtual devices in Reason and lock the recording lanes afterward. If you do get into this situation, don't worry, it's easily resolved. You can double-click on each virtual control surface and reselect the MIDI input again. This is where having matching port and device names comes in handy. You can then click OK, and the virtual device has a green check once again. Now you can lock a lane to this device again in the Reason sequencer. One last thing you'll need to do to record MIDI to a lane is to add any Reason player to that lane, turn it off, and turn on Direct Record. Do this wherever you want to record incoming MIDI and you're good to go. Great, let me fix my control surfaces and I'll come back to you for the next step. Now that I've locked all MIDI lanes to a virtual device, I'm ready to record this sketch. Once you have everything set up like this, I recommend that you set up a blank project as a template so that you're set up and ready for your next sketch. All right, let's hit record and play. All right, I'm done with this sketch and I have my MIDI data and my audio for this project. I've also recorded some automation for one of the Octatrack devices. I can now export this jam to audio to review later. I can also play it back in Reason. However, before I do that, I deselect Send Clock in the transport panel and mute the Multiclock channel so that the Multiclock isn't woken up by Reason. Then I can hit play. Now I have a complete recording of my jam to work it into a live set later or develop it into a track I might later release. One last thing I covered in my ADE Masterclass is an approach to jamming on the go if I didn't have my hardware with me. This is possible using Reason players instead of the MIDI coming from hardware. Here on the Octatrack Combinators, I have a drum sequencer sending a MIDI note to the NNXT. In the keystep combinator, I have a pattern from the polystep sequencer going into the analog lab. If I want to mutate this baseline pattern, I can chain a pattern mutator after the polystep sequencer and hit record. I can then turn off the polystep and work from the pattern mutator. Then I can mutate this pattern until I find a variation I like. I can then save that variation to a pattern slot in the pattern mutator and keep mutating it until I have more variations. Suppose I have a small MIDI keyboard controller, like this Q Mini. In that case, I can experiment with different chords or chord progressions using the chord sequencer here, or just playing the chords manually. This becomes a great mobile setup for sketching ideas on the go. I can then sequence these ideas into my hardware later or build a song directly from the Reason players. The possibilities are endless. All right, that was a ton of information. I hope that covered everything I might have missed in my ADE Masterclass. There is, of course, much more to this live set that I want to share, like all of the custom software I'm writing to get Reason to understand program changes from the Octatrack and automatically sync the Multiclock's tempo with Reason. And I'm also working on a special hardware build, getting the virtual Reason rack to show up in a physical way that isn't just plopping my laptop on stage with the rest of my hardware. Instead, I want the software to blend in with the hardware so I can play it like a piece of gear, an incredibly powerful piece of gear. But more on that later. Thank you for watching, and thank you to Reason Studios for inviting me to create this tutorial for their channel. If you want to support my journey in building this live set, please follow my YouTube channel where I'll be releasing more videos related to this topic. You can also support my label, Vault Wax, by going to vaultwax.bandcamp.com and buying some music. The releases are also available on vinyl through Clone Distribution. Lastly, you can follow me on Instagram at Beyun303. All right, thanks so much. I hope you're inspired to create something. Until next time.